So now in the end, you get a coherent patterns, circulation patterns in the ocean, which can be described in terms of gyres. Gyres are the largest coherent current pattern. And we have subtropical and subpolar. It's like in the North Atlantic. You see here this clockwise gyre. Okay? This is the subtropical gyre. And to the north of that, it's not very well shown here, but this is what we call a subpolar gyre. Okay, there's also subpolar gyre in the North Pacific. Very pronounced features are western boundary currents on the western side of these subtropical and subpolar gyres, and they all have names like the Gulf Stream, the Kuroshio, the East Australian Current, Brazil Current, and the Atlantic Current. And they are created by westward intensification. And it's a mechanism. So they're actually also responding to the large-scale wind stress curl over the gyres. Okay, if that wind stress curl is increased, or so, it also changes the speed of the western boundary current. And these currents are all horizontal currents, as explained before. Okay, we also have eastern boundary currents, and there are more created through coastal winds, Ekman layers that are created in interaction with the coastline. And they also have names. You can see Peru, Chile current, Benguela current, Canary current, California current. On the eastern side of these gyres, okay, we also have a circumpolar currents. One is called the Antarctic Circumpolar Current. It runs all around the Earth. And we also have a circumpolar current, which is not shown in this diagram, in the Arctic Ocean, in the Arctic Mediterranean Sea. There's also countercurrents here, and I'm not going to explain the dynamics of these, but you can see near the equator, there are countercurrents which actually run opposite to the wind direction, but are created by the wind. So the circulation in the Indian Ocean varies dramatically between the seasons due to the monsoons. And if you now focus on Australia, which is here also in this map, let's see, here's Australia, you can see Australia here. It actually has two boundary currents. Yeah? One is the East Australian Current, which is a western boundary current, but it has another boundary current which is called the Lewin Current on the western side. Okay? So that's an important feature. So now if you look at a map of these currents, and that's why I went so much into detail with the so-called baroclinic compensation, how the density fields adjust to that. With a look at this structure, you should actually get an idea of how does the internal density field in the ocean actually looks like. Okay? All right.